So yeah, I'm sure, but in the diagram here, APC is a tangent, no?
Yes.
And then it's a tangent to a circle with center O. This is very important.
Yes.
And then at B, like it touches the circle, it could have touched it at E, it could have touched it at D. So it's a tangent at B. Usually we'll talk about it's a tangent at B. And then they will say, prove a theorem. Once they say prove a theorem. Now I want you to notice there's also this question here. We can say to Elena, prove a theorem, or we can just say to Elena, prove. There are questions where I will just say prove which C is equal to D, for example. It's not a theorem, that one. Or prove which these lines are parallel. It's not a theorem. But once I say prove the theorem that states, then you're allowed to construct.
Quadratic, cyclic quad.
Yeah, prove something is a cyclic quad. They're not saying prove the theorem that states that opposite angles. If they want you to prove which opposite angles of a cyclic quad are supplementary, they will tell you prove the theorem that states that opposite angles of a cyclic quad add up to.
So even here, they are opposite angle. Both of find values. Oh, well,
we will check that one when we get to that one. But we construct, they don't give us any values.
Okay.
There's a certain way you should do it. Okay, what are we trying to prove here? What are we trying to prove here?
What a triangle. Angle DBC is equals to.
Let's check DBC. Which one is it? I get it. DBC. DBC is this angle here. DBC. So they're talking about this angle. Yeah. And then it should be equaling to what? It should be equaling to angle DEB, which is this angle. So that's what we're trying to prove.
Yes.
RTP, we are required to prove which this angle here is equaling to this angle here. Yeah? Now, what does the learner need to theorem a tangent? They need 90 degrees. That is very important. They need 90 degrees. And then how do you get 90 degrees? How do you get 90 degrees on cyclic quad on a circle? You can get it by using tan perpendicular to a radius. We have this theorem that says tan perpendicular to a radius. Huh?
Yes.
And then we also have another theorem which states which we have an angle in half a circle. We have this one, angle in half a circle. We do have that one. This one also gives us 90. So these are the two theorems that are going to give us this thing that we need. So now we need to get the 90. How do you get the 90? We need to have a radius. So how then do we get the radius? We're going to construct a radius. Because we need it. We're going to construct a diameter. Basically, we construct a diameter. So let's see, we have A, B, C, D, E. Let's construct, we're going to do a construction. We're going to construct a diameter BF. We're going to construct a diameter. Construct BF. So I have this line, which is a diameter from B, and then it goes to this thing here. F. I'm using any alphabet which is not here. Okay. And then after that, depending on what I'm proving, if I was proving, they could have asked me to prove which angle, this one, which is EBA. This one is equal to this angle here, which is angle EDB. They could have asked me to do that. But now that's not what we're trying to prove in this instance. In this instance, we're trying to prove this one is equal to this one. As soon as we constructed the diameter, we're going to join our diameter here. There are two ways in which we can join it. We can either join it to D or we can join it to E. Now, how do I know? I'm going to check what am I trying to prove. If I'm trying to prove angle D is equal to angle here, I'm going to join it to D. If I'm trying to prove, agree here, what am I trying to prove? I'm trying to prove which B is equal to E.
Yes. In the first place, why did you construct line BF?
Why did I construct? I constructed the diameter because I need 90 degrees. Basically, this theorem, you prove it by about 90 degrees. How do you get 90 degrees? You get 90 degrees from a line from the center perpendicular to a chord, which here, like, it doesn't work. Okay. So another way in which I can get the 90 degrees is if I have a tangent and a radius. Another way in which I can get a 90 degrees if I have an angle in half a circle, like angle in a semicircle. Okay. So that's the main, like as I was saying, which each and every theorem has its main story. Angle at center, you need to know with the main story that it's exterior angles of a triangle. So if Elena needs to know exterior angles of a triangle, that's the main character there. So if Elena understands the exterior angle of a triangle, then they will be able to prove that one. Yeah, Elena needs to think 90. Every time when they see this one, they need to think 90 degrees. And then they think of theorems that is going to give them 90 degrees. So AMA theorems that can give you 90 degrees, you need to have a diameter. You need to have half a second. That is why I constructed a diameter BF. Ne? And then after that, the other thing that I'm saying is this. If I am proving, let's say I was proving with this angle is equal to this angle, I was going to construct, I'm going to join D and F. And then in this case today, what am I trying to prove? I'm trying to prove which this angle is equal to this one. So it means that I'm going to go to F to E. Yes. So I constructed a diameter BF and I am going to join EF. I'm okay, I'm still there.
Yes, Mr.
Okay, so we construct and then we join EF. Now look at this here. Now. You have this angle here. And then you can call this one E1 and then you can call this one E2 so that it becomes a little bit simple. And then you can also call this one B1, and then you can call this one B2. Then you can start to work. Once you're done with your construction. Now, this is what you need. As I said, you need 90 degrees. Now, remember, number one, an angle subtended by a diameter. Which angle is subtended by a diameter? We have diameter BF. Which angle is subtended by BF?
I see angle E is
angle E is a whole, E1 plus E2. Yeah. In E1 plus E2, if you were to check here, if I go from here, if I were to move from here to here, then I move from here to here. So this whole angle here, it's subtended by a diameter. Meaning in other words, I can tell them which E1 plus E2 is going to be 90. Yeah? Why is it 90? Yeah, it's an angle in half a circle. And then I'll get a mark for this. I'll get a mark for doing the construction. So now all in all, I have 2. Okay, what else do I have? Let's look at this. I also have here, I have this angle, which is 1. This one is 2. I'm going to say, what is this angle here?
Perpendicular to radius.
This is a radius.
Yeah.
So I can tell them, would you B1 plus B2? They're also going to give me 90. And then when they ask me why P1 and P2 are giving me 90, I'm going to tell them it's because we have a tan perpendicular to a radius. So far, so good.
Yes.
My fellow Zoom learners, are you still fine?
Yes.
Okay. Now, the next thing that follows is this. Remember, what are we trying to prove? Basically, based on what I just said here, we're trying to prove which P1 is equaling to angle E1. Because that's what we had originally. Remember, we had this thing. We highlighted this one as red. Okay? Also highlighted this one as red. So we're trying to prove which P1 is equaling to E1. That's the goal. Now, when we continue, there is something that we also learned. Let's look at B2. Who created B2? Who's subtending B2?
It is subtended by FD.
It's subtended by FD. Okay? Yeah. Is there any other angle subtended by FD?
Yes.
FD.
Yes,
E2.
FD. This one.
Which doesn't exist.
It's an arc.
Or arc.
Yes, there is this arc.
E2.
And then this arc is creating, it's forming this angle here. Is there any other angle subtended by FD? The what?
E2.
E2. Yeah? Okay, I will tell them with my guys, look at this. B2 is going to be equaling to E2. When they ask me why am I saying this, I'm going to tell them these are angles in same seg. Get a mark here. I also get a mark here. And then you can clearly see it, man. Here. Here.
Yeah,
Yeah, it will assist. So you can tell them with this one and this one, they're equal. Okay? But look at this. This one plus this one, they give us 90. Okay? This one plus this one, they also give us what? 90. It's possible for me to say, Mara, these two people are equal. This one and this one, they're equal.
Yes.
Why are both of them equal?
Because they're equaling to 9.
Both of them are equaling to 9. Meaning in other words, B1 plus B2 is going to be equaling to E1 plus E2. And then by what you're saying which because both of them are equaling to 90. Like this. Eh? But look at this. B2 is equaling to E2 again. These two, they're equal, meaning they can cancel each other out. Remember in maths, if you have something like this, if you have 2x plus 1, which is going to be equaling to
2x
2,
plus 2x.
2x plus
2.
3. You can say these 2 and these 2, they're going to cancel each other out.
Yeah.
Again, if you take this one
To the
to this other side, this one is positive, and then this one is negative, then it does the thing that it does.
So mistake. You are wrong. Ngaira E2 lili E2x.
If you make B2,
Lili E2 did it.
yeah, you can do that. You can say this one, and then you let them to be x. So you come and write, but this is x. This one is also x, so that you can see with this one x and x they're going to cancel each other out.
Okay.
Yeah, this one and this one they're going to cancel each other out. Meaning, therefore, B1 is going to be equaling to what to E1, which is what we're trying to prove all along here. We're trying to prove which B1 is equaling to what to E1. Therefore, it means DB angle DBC is going to be equaling to angle DEB. And the number marks were called I5. Again, we got 1 mark for construction. We got 1 mark for this 90. You got this 1 mark for this 90. We got this 1 mark for this 90. And then we got 1 mark for this one. 1, 2, 3, 4, 5. And then you're done.
DBC agar and DBC
Yes.
because
I can erase it so that you can try it on your own.